Welcome friends. Today we discuss about solve some problems related to fifth unit. Okay, already I explained the psychrometric chart. The chart having x-axis is stable temperature and y-axis is humidity ratio. Nothing but specific humidity or moisture content. Unit is kilogram per kg of air or otherwise gram per kg of air. Okay, and some more values are plotted in the uh, psychrometric chart. Those are specific volume. The specific volume lines are the this is a specific volume lines, and the wet temperature lines are is 45-degree inclined, and specific volume lines are slightly inclined with vertical. Okay, very steep lines. You can, if you have a point in between the two lines in the chart, they have mentioned different values. For example, in wet bulb temperature they are giving 20 and 25, but I need wet bulb temperature for 22. I approximately said this is the wet bulb temperature of 22. Okay, 22. Similarly, the relative humidity, those are 50 and 60. Okay, but I need 55. That line is lies in between like this. I can approximately I can assume, or I can draw that in between values. Okay, you can understand this concept. These things are the psychrometric chart, and the data. This is the enthalpy line, and this is the Woodruff line, y-axis. These things. Okay, already I detailed explained the psychrometric chart in previous classes. Okay, today we discuss about the psychrometric problem related to psychrometric chart. What are the psychrometric process? This is also discussed in earlier classes. Those things: sensible heating, sensible cooling, and humidifying, dehumidifying, and adiabatic mixing, and evaporate cooling. Okay, this is some important psychrometric process, and also some combination of process also there. Okay, also some combination of process is there. Okay, those are cooling and dehumidification, heating and humidification, such things. Okay, then today we discuss the problems. One is atmospheric air at 1.0132 bar has reliable temperature of 40 degrees Celsius, and WPT means wet temperature is 25 degrees Celsius. Find its RH. The 2 mark question. Atmospheric air at 1.013 bar is atmospheric pressure. So no problem. The main data is the dry bulb temperature is 40 degrees Celsius and wet bulb temperature is 25 degrees Celsius. Find its relative humidity. Okay. First of all, first we locate the values in psychrometric chart. If you find out any value in a graph, we need two values. We need two values, x and y value, or any two parameters. This is mandatory. Okay. In other ways, we cannot locate the point. But in some cases, we need one value or zero value. For example, origin of the graph is one point. Okay, but if we want to locate that point, it doesn't have any data. Okay, because the origin is 0, 0 comma 0. It's everybody knows. And another example, if you locate a point in a x-axis or y-axis, you need any one point. The other value is 0. For example, if you locate the point in x-axis, what is the x value and y value is 0. Similarly, if you want to locate a point in y-axis, y value, y having certain value, x value is 0. Okay, this 0 comma 4 or 4 comma 0. At that instant, we need only one data. But in the region, the space region, want to locate any point, we need two data. It is mandatory. Okay. Therefore, in that problem, they are giving two data. One is stable temperature, another one is withdrawal temperature. Okay. What is the relative humidity at that particular point? The question. Okay. First, explain with my rough diagram. It's a psychrometric chart. First, we locate the point. The dry bulb temperature is 40 degrees Celsius. Therefore, in dry bulb axis, you take 40 degrees Celsius and put a vertical line. Okay, put a vertical line. (40°C). Put a vertical line. Okay, 40°C. You put a vertical line. Sorry. From 40°C. Okay, then another data is 50%, sorry, 25 degrees Celsius. 25 degrees Celsius WBT. In the WBT is located in an inclined manner, which is this is the WBT for 5, 10, 15, 20, 25, 5, 10, 15, 20, 25. Okay, for I need this value only. Therefore, from 25, I draw the line in parallel to the enthalpy line. Is wrong. Yes, the horizontal line is wrong because the withdrawal line is the inclined line. Therefore, if you follow the inclined line and intersect the that vertical line from the 40°C stable temperature. Okay, therefore we get one intersection point, which is our required point. Okay, again I tell we have two data. One is WBT and another one is dry bulb temperature. First, what the dry bulb temperature is 40°C. From the x-axis, from 40°C, draw a vertical line, and then WBT lines values are in the attached in the extreme curve. Therefore, the value is 25°C. From the 25°C, draw a line is parallel with the inclined line. Okay, not a horizontal line. Okay, so parallel with the inclined line. Therefore, the two lines are intersect at a one point. That point is our solution. Okay, from that solution, what is the curve? This curve is represent the relative humidity. Okay, it's a incline curves starting from bottom to the top is a relative humidity lines. Okay, already I said. Therefore, at the particular point, that passing curve is our solution. That value is nearly 30%. Okay, because that relative humidity is 10, 20, 10, 20, 30, 40, likewise increases. Therefore, approximately I draw the values. I get one intersection point At that point, the value is approximately 30%. Okay, answer is relative humidity is 30%. Yeah, this is the how we this how we find out the unknown values with the help of known values. Okay, first we locate the point with the help of these data, and then once we locate the point, then we find out the another data intersect or passing through that point. Okay, thank you. For example, in the problem, if we calculate, they are also asked what is the specific humidity, the moisture content. Therefore, from that point, I mark one horizontal line which points that value. This value is the specific humidity or moisture content. Okay, for example, 10, 15. Here 10, here 10, here 15. Therefore, our value is in between the 10 and 15. Therefore, approximately I take 18 gram per kg of dry air. Okay, which is the approximate answer, because in the chart you cannot measure the accurate value. Okay, some human error are there. Okay, this is one type of problem. Then next problem. Next problem also similarly like that problem. Once you understand clearly, then you can easily solve the fifth unit problem. Okay, and second problem is atmospheric air at 1.0132 bar has 20 degrees Celsius dBT, 20 degrees Celsius dBT and 60% latent. Okay, that in previous problem they are giving dBT and WBT. Okay, but here the two data are dBT and latent humidity. Okay, find the humidity ratio, which is nothing but omega, specific humidity, and overall temperature and dew point temperature. Okay, dew point temperature TPT. Okay, and enthalpy of mixture. Okay, this is also a very easy problem. First we locate the point in psychrometric chart. First primary, from 20 degrees Celsius I draw a vertical line, then the next data is 60% relative humidity. Okay, 60% relative humidity. And this likewise the relative humidity lines are there. In that line we is 40%, 50%. Therefore, at 60% I draw imaginary line. Okay, that vertical line and the curve is intersect one point. That point is our location. Okay, from that point horizontally I draw a line from left to right is shows the specific humidity value. Okay, and also from that point I draw a line from right to left, and for top to it touches the extreme curve. From that curve draw a vertical line. Here we get the dew point temperature. Okay, then likewise from that point I draw a line in the inclined manner. I get a WBT at the extreme lines, extreme curve. Further extend the line, it intersect the entropy enthalpy curve, it shows the enthalpy value. And all unit of the every values is given in the psychrometric chart. Okay, you don't bother about it. Okay, once again I tell the psychrometric chart. This is the chart. The given values are 20 degrees Celsius. Therefore, from 20 degrees Celsius, I draw one vertical line. So 20 degrees Celsius, I draw vertical line. And remaining value is 60% relative humidity. The 60% relative humidity value is this. The 60% relative humidity value. Therefore, I get an intersection point. Okay, from that point, draw a horizontal line. We get the specific humidity value from this. The specific humidity value. Therefore, the value is in between 5 and 10. Therefore, I can take the 9 kg per kg dry air, because that line is closely matches to 10. Therefore, I take 9.9 or 9.8. Okay, you can write the answers. Then the dew point temperature is, draw the line from right to left. It touches the saturation curve. From that, draw a vertical downwards line. It shows the temperature. The temperature is nearly in between the 10 and 15. Therefore, I can take 11 degrees Celsius. Okay, which is my approximation. Then from that point, I draw a line parallel to the inclined lines. It touches the saturation curve. At that point, I get the WBT value. In that solution, that value is in between 15 and 20, but that point is close to with 15. Therefore, I can take the values as 16 degrees Celsius. Okay, then further extend that enthalpy to next stage. Further increase the extend the line to the enthalpy scale. It shows the enthalpy values, which is also approximately 45 to in between the 45 and 50. Therefore, I can take the 46 kg per kg of dry air. The unit is given with the values: kg per kg of dry air, degree Celsius, meter cube per kg of dry air. Here, moisture content is grams of moisture per kilogram of dry air. Every unit is attached with the heading. Okay, therefore you don't memorize the units. This is the second example. Okay, so first and second example both are the same, but the input data are different. In the first example, dry bulb temperature and wet bulb temperatures are given, but in second example, dry bulb and relative humidity is given. Okay, with the help of these two values, I can find out that location, and from that location, I draw some another lines. That another lines shows the unknown values. Okay, this is the problem from fifth unit. Okay. Furthermore, we have two more problems in that unit. Okay, which will be discussed tomorrow. Okay, thank you. That values. Welcome, friends. Today we solve two more problems related in psychrometric process. Okay, so let me start the problem. In previous class, I explained two types of problem with this, which mainly focused for the particular location of a air, particular condition of a air, which is located in a psychrometric chart, With the help of that location, I can find out the remaining parameters. Okay, which is the structure of a previous problems. Okay, but today I discuss some process, because already we discussed the psychrometric processes: sensible cooling, heating, adiabatic mixing, evaporative cooling, these things. Okay, okay. From so today I solve the example for that concept. Okay, okay. So let me start the problem. Air at 20 degrees Celsius and 40% relative humidity. Air at 20 degrees Celsius and 40% relative humidity. Okay, here 20 degrees Celsius. In the problem, they are clearly not given. The temperature is either dBT or WBT. Okay, I can assume that value is dBT, because WBT, if they are mentioned WBT, they are particularly give the notation for that. Okay, but in dBT it is not mandatory. Okay, therefore air at 20 degrees Celsius means 20 degrees Celsius dBT and 40% relative humidity is mixed adiabatically with the air at 40 degrees Celsius and 40% relative humidity. Okay, mixed adiabatically. Okay, therefore first air is mixed adiabatically with another air, but the condition is different. The first year, initially the air is 20% and 40% relative humidity is one branch, and secondary air, which is at 40 degrees Celsius and 40% relative humidity, is secondary air. Both are mixed in a container, and then introduce a new property and new condition of air. Okay, and in the ratio of 1 kg of farmer. Okay, which means first year, 1 kg of farmer and 2 kg of latter. Latter is secondary year. Okay, first one is primary. I notated as first one is primary year and second one is secondary year. The primary year temperature is 20 degrees Celsius and 40% relative humidity, and secondary year is 40 degrees Celsius and 40% relative humidity. Okay, then mass flow rate of the mass of the first primary year is 1 kg and mass of the secondary year is 2 kg. Okay, find the final condition of air after mixing. The condition of after mixing. Okay, this is the best example for adiabatic mixing, and also best example for the centralized AC concept. Okay, what is centralized AC concept? In previous classes we had a discussion about that. Okay, in centralized AC concept, in a centralized unit which will produce a very very chilled air, which is called primary air, is mixed with atmospheric air and it is converted in the atmospheric air having a higher temperature and the chilled air having very low temperature. Both are mixed in a adiabatic chamber, and output of the adiabatic chamber having different, which is the comfort condition. Okay, which that air is the supply air to the supplier of a particular supermarket. Okay, in the problem is the best example for the centralized AC concept. Okay, here the primary air is from centralized unit and secondary air is from atmosphere. Both are mixing and create and converted and change its condition due to the mixing of the two streams, and that conditioned air is supplied to the supermarket. Okay, then now we go to the problem. Thus dBT 1 20 degrees Celsius and relative humidity 1 40 degrees Celsius. This is the primary air. It is nothing but cold air because the temperature is lower. Then second mass is equal to 1 kg. Then secondary air is 40 degrees Celsius and relative humidity 40%, called hot air. In both the cases, the relative humidity is not changed. Okay, so both are same. Okay, only temperature is temperature alone is very different. Okay, from those two types of air. Okay, then mass flow rate is equal to 2 kg. This is the given data from the question. schematic diagram for the adiabatic mixing. Here dBT primary air, dBT 20 degrees Celsius, RH 40% and mass 1 kg is flow one branch of tube, and the secondary air dBT 2 and 40 degrees Celsius, dBT 2 40 degrees Celsius and relative humidity 40% and mass 2 kg is also passed in another branch of tube. Both are mixed here. Okay, then we get a new condition of air. Okay, which is m3 we know here m1 is equal to 1, here m2 is equal to 2, therefore that m3 equal to 1 plus 2 equal to 3. Okay, it's a very simple calculation. And what is the relative humidity and what is the dBT? It's the unknown values. Okay, m3 is very easy. Okay, mass balance. The mass balance m1 plus m2 equal to m3. Okay, that m1 that m2 which is equal to m3, therefore m3 equal to 1 plus 2 equal to 3 kg. Simple calculation. And another thing is energy balance. m1h1 plus m2h2 equal to m3h3. So enthalpy, energy, the input, this is h1, this is h2, this is h3. Okay, for m1 h1 plus m2 h2 equal to m3 h3. So energy, total energy of the stream. Okay, m1 h1 m2 h2 equal to m3 h3. It's the energy balance. It's the formula for adiabatic mixing. Everyone remember that formula. The formula for adiabatic mixing. Okay, for mass balance is input mass is equal to output mass. Input mass is two branches, one is primary air, which is m1, and secondary air is m2, then mixed together, then creates m3. Okay, from that m3 equal to the summation of m1 plus m2 equal to 3 kg. Then similarly the energy balance, the input energy which is equal to output energy. Okay, input energy is equal to from first law of thermodynamics. Okay, study for energy equation, these things. Okay, from this concept I can derive that equation. Okay, m1 h1 plus m2 h2 equal to m3 h2, energy balance equation. Okay, from that m1 m2 m3 is known values. m1 equal to 1 kg, m2 equal to 2 kg and m3 equal to 3 kg. And in that problem they are given two locations. Two locations means first condition, primary air condition and secondary air condition. Okay, primary air condition is h1 and secondary air condition is h2. Okay, first we locate the psychrometric chart. First the condition of two types of air is located in a psychrometric chart. Okay, this is the first case. Let me start the psychrometric chart. Okay, this is psychrometric chart. Okay, first you locate the many time I explained with the psychrometric chart, but in that case first I explain the my rough diagram and then we go to the psychrometric chart. Okay, then number 1 is a condition of primary air and number 2 is condition of secondary air. Okay, primary air is cold air, secondary air is hot air. Okay, then first 20 degrees Celsius and 40% relative humidity is the condition of primary air. Okay, then from horizontal line extend a vertical line from the 20 degrees Celsius, and many number of relative humidity lines are goes like this. From this 40% relative humidity line is intersect the particular point. It is noted as the first point. Okay. One by one, I explain my rough work and also chart. Okay, first you locate the first point from 20 degrees Celsius, extend a vertical line. Okay, from and the 40% relative humidity. 40% relative humidity is this. Therefore, the 40% relative humidity line, and the both lines are intersect a particular point. It's called first point. Okay, it's called first point. 20 degrees Celsius and 40% relative humidity called first point is condition of primary air. Then second, the secondary air temperature is 40 degrees Celsius. Therefore, from 40 degrees Celsius, extend a vertical line. Okay, and relative humidity is what? The same as compared first case or primary air. Then extend the line, that same 40% rating line, and intersect one point. Okay, this is the second point. Okay, first case 20 degrees Celsius 40% rating humidity, second case 40 degrees Celsius and 40% rating humidity. And through straight line connect these 2 points. Below line is a curve line, but top line is a straight line, like this. In that, the below line is a relative humidity line, but I join a straight line. For straight line is a adiabatic line. Okay. Once I locate the points, then I extend the line from that point 1 and 2 to the enthalpy scale. Enthalpy scale. Line parallel to the Vedrol scale. Here H1, here H2. Okay, here H1 and here H2. H1 and H2. Okay, then from the psychrometric chart, we get H1 equal to 34 kilojoules per kg and H2 is equal to 92 kilojoules per kg. Okay, therefore in energy balance equation, in energy balance equation, M1H1 plus M2H2 equal to M3H3. Therefore, M1, M2, M3 already known. With the help of psychrometric chart, I take the H1 and H2 values also. For the remaining thing is H3. Okay, so it's an unknown value from the equation. Substitute the known values in that equation. One mass M1 34 plus 2 into 92 equal to 3 into H3. So from that equation, H3 equal to 72.67 kilojoule per kg. This is nearly equal to 73. Okay. Okay. Now we get the H3 value. Okay. Then you locate the H3 value in chart. Okay. First you locate the H3 value in psychrometric chart at H3 scale. Okay, let me start. The H3 value. Locate the H3 value 76. The psychrometric chart. Psychrometric chart. Locate the H3 value. Then from that H3 value, extend the line up to the line joining in between the 1 and 2. Okay, it intersects. Here H3, extend the line from H3 up to the line 1 and 2, that both lines are intersect. That point is our required point. It's a final condition of the air. Okay, the problem is over. Then with the help of the chart, draw a horizontal line, we get omega 3, and draw a vertical line, we get dBT3. Okay, so final condition of air. And the below line is 40%, 40% relative humidity, but that point is slightly higher than the curve. Okay, the point is slightly higher than curve. Assume that line is 40% line is 40% relative humidity line is this. Okay, 40% relative humidity line, but that point intersection point is slightly above that line. Therefore, but this point having also different relative humidity. Oh, therefore I can assume that relative humidity is 42%. Okay, 42%. Okay, therefore the problem is over. Uh, 42% dBT 34 degrees Celsius and omega equal to 19 grams per kg of air. Okay, with the help of the psychrometric chart. So this is another type of example. Then we go to the fourth problem. It's a very simple problem. So 200 meter cube of air per minute. 200 meter cube of air per minute at 15 degrees Celsius dBT and 75% relative humidity is heated until its temperature is 25 degrees Celsius. Okay, 75% relative humidity and 15 dBT heated until its temperature 25 degrees Celsius. Okay, the problem is related to sensible heating because temperature is only changed from 15 degrees Celsius to 25 degrees Celsius. Okay, 25 degrees Celsius, fine. Relative humidity of heated air, threshold temperature of heated air, and heat added to air per minute. Okay, that's a very simple problem. The given is volume 200 meter cube per minute and dBT 15 degrees Celsius and relative humidity 175% and dBT 2 is 25 degrees Celsius. Okay, first we locate the data in a psychrometric chart. First we locate the dBT 1 and RH 75. So from 15 degrees Celsius, so 15 degrees Celsius can draw a vertical line and it intersects the 75% relative humidity line. It's noted as a 1. From 1, draw a horizontal line because sensible heating line is a horizontal line. And from 25 degrees Celsius, draw a vertical line. So both lines are intersect at one point, which is called 2. Okay, it's a notation. Then now we take the values from the chart. Okay, first number 1, take the H1 values, and number 2 take the H2 value and WBT values. If just extend the line, we get the values, and at point 2 having another relative humidity line passes through another relative humidity line which is equal to 40%, and also the point having a specific volume line which is equal to 0.86 meter cube per kg. Those things is taken from the chart. Okay, I explain the chart. Okay. First you locate the 15 degrees Celsius and 75%. 15 degrees Celsius. From 15 degrees Celsius, draw a vertical line and 75%. In that chart, we have 70 and 80. Therefore, in between the 70 and 80, I draw one line. The first point. From first point, draw a horizontal line. Then from 25 degrees Celsius, I draw a vertical line. 1. It intersects the horizontal line, which is 2. And the point 2 also having a latimeter line, which is equal to 40%. Okay, then from point 1 extend the enthalpy scale and point 2 extend the enthalpy scale. We have H1 and H2, and this curve in the enthalpy saturation curve, we have the WBT temperature, and from 2 the vertical inclined line is passing, which is the specific enthalpy, which is equal to 86.86 meter cube per kg. These things are taken from the chart. Then now first we calculate the mass flow. In the problem they are giving volume flow rate, meter cube of minute is given, but we need mass flow rate. It is something but kilogram per minute. Therefore total volume is 200 and specific volume is taken from the chart. This is equal to 0.86. Therefore we get 232.55 kilogram per minute. This is the total mass flow rate of the air. Okay, then heat added per minute. The remaining things are total temperature is 16 degrees Celsius from the chart. Okay, from point 2 extend the line to the saturation curve. Therefore we get the total temperature, and further extend the line we get the enthalpy. Point 2. Therefore substitute the H2, H1 and M. We get the heat added value. It is equal to 2325.58 kilojoules per minute. This is the answer. Therefore total temperature is 16 degrees Celsius and the relative humidity is 40%, and heat added per minute is equal to 232.5.58 kilojoules per minute. Okay, this is the two types of problem. With the problem, I can conclude the fifth unit. Okay, thank you.